looks like it's time, so I'll get started. Hello, everyone. My name is Tyler, and today I'm going to be talking to you about how we at Yelp went from a Pandora's box of spaghetti code to a nice and organized Bento box of modular and reusable user interface components. Specifically, I'm going to be focusing on how you can also use the Bento framework in your existing app to transition from a legacy setup to something that's way more maintainable and testable without having to rewrite your entire app or even individual screens from scratch. So first, I'll talk a little bit about Yelp and what we do. So what we do is we connect people with great local businesses. Pretty much all of our features and products kind of center around that one idea. I work on the search user experience team, or as we lovingly refer to it, sucks. And our product is kind of at the heart of connecting users with great local businesses, right? Users come to Yelp searching for a business, and we help them find that business. So we're responsible for a few different things. One of those things is making and keeping search fast. We also want to allow for effective experimentation on the search page, so making it easy to add new features and test out whether or not they're actually successful. And we kind of act as a platform for other teams as well. There are a lot of teams at Yelp that want to showcase their new feature in search results in some way. And so they will come to our search page, not necessarily having a lot of experience working with it. They'll add their feature, and then they will leave after. And that means that our code on the search page needs to be easy to read, understand, and also modify. So Yelp for Android has been around for a long time now. I actually went through the Git logs and found that the first commit was back in December of 2009. And even then, they mentioned something about SVN, so it might actually be older than that. And search was a feature that was launched in the app when it first came out. This is actually a screenshot that I took a few days ago of the original APK. So it still runs on our emulators today, but for some reason the backend wasn't quite liking what we were giving it. Might have something to do with the fact that it was about a decade apart, but it did work a year ago, so I'll have to figure out what went wrong. So search was a feature in the app when it launched, and we're still using the same code base today. And that means that over time, we've kind of accrued a lot of tech debt. There's a lot of spaghetti code, things that have little to no tests or very flaky tests, and many features that have kind of piled on top of each other to create this kind of legacy lasagna. I must have been hungry when I wrote this. And so for those of you who don't know, this is what the Yelp app looks like pretty recently. This is actually Yelp in 2018, so before we converted the search page to use Bento components. And so I'll briefly kind of go through the architecture that we were using and kind of explain how it was getting a little bit out of hand to add new things to the search page. So I kind of refer to it as the ancient ways, even though it's not all that ancient, 2018. But first thing is that we were using a custom implementation of a list view. So that's bad for two reasons. Number one, because it's a custom implementation. And number two, because it's a list view. There's really no real reason why you would want to use a list view over a recycler view. But you don't have to take my word for it. You can also look at the official Android docs. They say for a more modern, flexible, and performant approach to displaying lists, use RecyclerViews. So they're hinting pretty heavily that you probably shouldn't use a list view. So how come we didn't just switch to RecyclerView when that came out? Well, we have a lot of legacy logic that is kind of wrapped up in our old list adapter classes. And if we wanted to switch to a RecyclerView, we would probably have to do it in a way where we made the migration all at once. And that is typically very costly and prone to scope creep and other things. And so what we had for our list adapters was we had this thing called a sectioned adapter. And so the way that the section adapter works is that it will wrap many other list adapters and use those nested list adapters to show views in a list. And so say you wanted to show something like an alternative search alert. So here I tried searching for hot Doge, and instead I probably wanted to search for hot dogs. And so we have this one view at the top. So the way that it would work with a section adapter is we would have one list adapter for our special view at the top, and then we would add another list adapter underneath for different types of views. And so it's a relatively reasonable approach. It probably made sense a while ago. If you look at the Java doc here, This is actually based on a blog post written by Jay Sharkey back in 2008. And if you actually click on that link, the blog post is no longer there. So that makes me a little bit nervous. I start to sweat when I see that. But I mean, we have the code here, and it seems to be pretty well documented, so maybe it's okay. So this is how you'd actually use the section adapter. You create a new instance of it. Then you would create the one list adapter per type of view that you wanted to add. In this case, if we wanted to add the alternative search panel adapter, so something that would recommend a typo, then we could create that adapter and add it as a section with an ID in case we wanted to retrieve it later. But I don't know if you noticed this, but what is this? Better sack of views adapter. I don't know about you, but I get nervous when I see classes that are prefixed with better. So let's jump to the definition of this class and see what's going on. Okay, so it's a class that extends something called a sack of views adapter, and it adds some small niceties to make it easier to use. And it says that it's actually using the sack of views adapter is a commonsware sack of view adapter. So I did some research and I found it online on GitHub, and it looks like the most recent code change to that library was about 3 years ago, which for open source probably isn't too bad, to be honest. But it looks like there was an even more recent update to the README only 6 months ago, so that's pretty good. Let's go ahead and see what they say. This project has been discontinued. The repository will be made private on June 1st, 2020. That is not good. So we won't even have access to the source code for this list adapter that is backing all of our search code on June 1st, 2020. But I mean, maybe it's not the end of the world. We could always just clone the repo and mirror it locally, right? And keep on trucking. We could, but then if we actually look at all of the different types of list adapters that we have that make up the search page, then there are 11 different adapters here for different view types. And it quickly gets out of hand really quickly because we have different custom adapter types, and they're being duplicated. There's some for above ads and below ads, bottom ads divider adapter. I don't know what that does. So it's really not that great. And every time a new team comes in, they want to add a new type of view to the search list, they would have to create maybe a new adapter because the old adapters aren't suited for their new view. So they're just adding more onto the pile, and this list grows and grows. And of course, the best part, very few unit tests. So all of these adapters are very tightly coupled to the Android library. And so in order to test them, we actually have to spin up the entire framework. And so we were covering these things using espresso tests that were oftentimes pretty flaky. And so hopefully now you have a better idea of why we couldn't just switch right away to using a recycler view. We still had to use all of this logic that was kind of wrapped up in these custom list adapters. So this is where Bento really came in handy for us, because Bento allowed us to make the transition from what you just saw to a much more maintainable solution more iteratively, instead of just scrapping what we had and starting fresh again, which is often costly, prone to scope creep, and puts a freeze on any other feature development on the page while the new screen is being built. So here we are, Yelp in 2018 again. And this is right before we converted to Bento, and then I'm going to show you what the app looked like right after we converted everything to Bento. So here goes, big reveal, 3, 2, 1. Wow. It looks almost exactly the same. And that's kind of the point too, right? We didn't actually want the end user to see any kind of difference after we made these changes. We just wanted it to be a better developer experience and something that would allow us to build more features more quickly on search. And so I'm going to put these two before and after side by side. Can anyone point out any differences between the two? A line in the hamburger menu, that's true. That's a good one. Anyone else? Okay, yeah, I think that's what you were referring to too. So there's a notification, that's true. And I will explain, there are a few other differences too, and I'm gonna go through all of them right now, because I think it's important to go through them just to give you an idea of kind of how Bento has helped us too. So the first difference, which unless you have binoculars, you probably couldn't see, these two screenshots were taken 1 minute apart. And that might seem insignificant, but it means that we can add Bento components into our app as an experiment. And we can quickly swap back and forth between the status quo of our legacy adapters and the new Bento experience. So it's really valuable for running experiments at scale. And it's also valuable because it means that we can test changes locally and swap back and forth between the two. The second difference that you might be able to tell kind of is that the last business at the bottom of the screen has actually moved up very slightly. And so the reason why that is because with Bento, we were able to control our vertical spacing a lot more easily. So this list on the right-hand side, the after screenshot, is actually comprised of view components. And what you often get when you're trying to compose views in this way is you'll have one view on top, one view on the bottom. The view on top will have some padding or spacing on the bottom of it, and the view on the bottom will have some margin or padding on the top of it. And you kind of get this like awkward white spacing in between, right? So what we've done with Bento is instead of making each component responsible for its own spacing, because it doesn't necessarily know what component it will be adjacent to, we instead created special divider components to handle that spacing for us. So we have our contentful component with no top or bottom spacing at all. Then we can slide in a divider component and then our next contentful Bento component. And that allowed us to really control the vertical spacing and made our design team happy too. And the third difference was that I searched for movers, and these are all auto mechanics. So no one seemed to call that one out. And the notification thing was actually because I logged in order to activate the Bento experiment. And when I logged in, I had a notification. So that was a sharp eye. That's true. That's probably, I'm not sure why that is. I'll have to check that out after. Very good eye. Cool, so now that we've done the conversion, I'm going to talk a little bit about what Bento is and how it works. So Bento is an open source framework right now. You can see it at github.com/yelp/bento. And Bento is a framework for building complex, modularized Android user interfaces. So the idea behind Bento is to make it easy to compose various reusable visual components onto a single screen. So why did we call it Bento? Well, if you look at this Bento container here with some food in it and our Yelp app, you can start to notice certain similarities. The chicken, for instance, kind of looks a little bit like the title. Then that little rice divot right below it kind of looks like the search bar, actually. And if you keep going, this is kind of like category icons right here, and then even the vegetables over here, it's kind of like a carousel, right? I don't know, maybe I'm pushing it, but fundamentally, Bento is about arranging visual elements of a screen into isolated components that can be added, removed, and tested individually. So here we have a Bento component. This is what we call a search list business info component. That's a little bit of a mouthful, so I'm just going to refer to it as a regular business component, and it's what displays information in the search list. This is for a business called Gary Danko, which is my favorite business that I've never actually been to. And this component displays all of the information about a business in our search results. So in Bento, a component is kind of like its own little MVP ecosystem. There is the model that holds the data of what's supposed to be shown. There's a view that actually displays that data. And then there's a presenter, which handles business logic and other user interactions. In Bento, we kind of refer to them by slightly different names. The model we usually call the item or data item. The view, we'll typically refer to it as a view holder, and we're kind of piggybacking on RecyclerViews and that kind of terminology. And the presenter we will typically call the component. So let's go through each one of those and see what it looks like. For our model, it's typically, or for our data item, it's typically a data class. So it's what provides data for the view. And usually what we do is we build the model beforehand and then pass it into the component's constructor so that it can be used in the component. That's usually what happens. Sometimes we can also pass in some initialization data so that the component can build its own data item instead. And it's typically maintained by the component, and anytime there's a change, the component can notify the view to update. And so what does that look like in code? It's just a typical data class. In this case, we have our business view model, which has a business name, position, the number of reviews that the business has, and we also have some variable properties like whether or not the business is bookmarked. We also have our view holder, and the view holder is very similar to the RecyclerView view holder, and it has two very important methods, inflate and bind. So the inflate method is kind of analogous to the onCreateViewHolder method of a RecyclerView, and the bind method is analogous to the onBindViewHolder method of the RecyclerView viewholder. They both kind of do the same thing. Now, a viewholder in the bind method is given a reference to the presenter and the data items so that it can do the actual binding. So it'll take the data from the data item and bind it to our views in our view, and it will also take the presenter and call methods on the presenter whenever we want to handle some kind of user interaction. So here's what it looks like in code. We have our business viewholder class, which extends the component viewholder class from the Bento framework, and it's using generics. So it wants to know what the presenter type is, which in this case is our business component, and what the data item type is, which in this case is our business view model. And so we have an inflate method and a bind method. In the inflate method, we inflate some XML layout file, and we get a handle on the different views inside of that XML layout that we've now inflated. So in this case, we get a handle on the text view that represents the business name. Then in the bind method, the view holder is provided with the presenter and the data item. And in this case, we take the business name text view and we bind the business name from our data object to the text view text. And then we have our component, which is a very important class. This is the class that actually interacts with the Bento framework. It notifies when the UI has data, when the UI needs to be refreshed because data has changed, and it provides a data item and the view holder class to the framework so that the view can actually be rendered. The good thing is that it's separate from the Android ecosystem, which means it's very easy to unit test. And that means we don't have to build the entire app to actually run our unit tests. So here's an example of the business component. The business component has 4 main methods that it overrides from the component class in Bento. The first one is the getItem method. So that method will actually return the data item that we will use when we're binding our view. The second method is the getCount method, and that returns the number of internal items that the component has. And I'll explain what that means in a little bit. The third method is the getHolder type. So this will actually return a viewholder class type so that the Bento framework knows which viewholder to use when inflating and binding this component in our view. And the fourth and final method is the getPresenter method, which will return the instance of our object that we want to use as a presenter for this component. In this case, since we're not really doing any user interaction or anything fancy like that, we can just return the component class itself, which is typically the case. So now we kind of know what a component is and how does it actually end up on screen. So that magic happens in our component controllers. And so a component controller is a special view controller that allows modular composition of complex views via self-contained components. Wow, that's a mouthful. Essentially what it does, though, is it wraps a view. The component controller will wrap a view, say a RecyclerView. So when you create a RecyclerView component controller, you provide it with a RecyclerView. Then what it will do internally is it will provide an adapter to that RecyclerView. Then what we can do is we can add components to our component controller, and it will maintain that list of components internally and update the adapter so that the adapter can display our views. And the cool thing about the component controller is that it provides a consistent interface across many different view types. So we don't necessarily need to have a RecyclerView component controller. It could also be something like a ListView, which would help us out for our legacy stuff that we were looking at before. And so this is what the component controller interface looks like. It's not super important to go through each of these, but this just kind of gives you an idea. So you have a component controller, excuse me, where you can get the index of a component, add a component, remove a component, add a list of components, clear everything if you even wanted to. And it's just a consistent interface that we can use no matter what type of view we have. So here is an example. We have the onCreate method of an activity. And in the onCreate method, we set the content view to some activity layout that contains a recycler view. We then create our RecyclerView component controller and pass in the actual RecyclerView itself as the first argument. And then on the controller, we can just call add component, where we want to add a new instance of our business component that we were looking at before. So our business component is provided with a business view model with the business name of just Gary Danko. And like I said before, it doesn't have to be necessarily a recycler view. We can also do this with a view pager too, and it's the same idea. The component controller kind of abstracts how the view actually renders everything. All we have to worry about is components. And so just for fun the other day, I took the search page in the Yelp Android app and I replaced the recycler view with a view pager. And so we have here a horizontal search page. And now you might be thinking, how come there's a space between every different result? And that would be because we're actually showing the divider components too. So every single component that we added, we show here in our view pager. And of course, we can use a ListView component controller for all of our legacy things too. So how do we convert what we had before in the ancient ways to a more modern Bento approach? Should we just use a brand new ListView and wrap that in a ListView component controller, start adding our new components, and then go that route? Well, if we did that, then why even start with a ListView? Why not just jump straight to a recycler view, right? So that has a lot of the same problems that we mentioned before, where we're basically recreating everything from scratch. We'll have duplicate views or components, and new features will need to be implemented twice, especially if the new search page isn't ready to launch yet. So we need a more iterative approach where we can start converting things more slowly. So here's our business component class from before. And I kind of mentioned this earlier, but we're going to focus a bit more on the getCount method of the component. So getCount, what it does is it returns the number of internal items in a component. So that means that a component can have more than just one item. We can have a list of items instead. And so the component controller, when it wants to render a component, it will ask the component, hey component, how many items do you have? What is your count? So it will call the getCount method on the component, and that will return the number of internal items that component has. Then for each, so let's say our getCount method returns 1, like in this case. Then the component controller will say, okay, great, 1 item. I need to manage 1 view in this place. So it will call getItem with a position of 0, and the component will return its item. Then the component controller will call getHolderType to try and get the view type that it needs to inflate. So getHolderType will be called with a position of 0. The viewHolder class will be returned, and then the component controller will instantiate it through reflection. And then it will call getPresenter with a position of 0 to get the presenter class. Then using that viewHolder that it created, it will call inflate and bind and pretty much call it a day. So now let's see what happens if we have more than one component. More than one item. So here we have a texts view component. So instead of just taking one view model as in its constructor, it will take a list of strings. So it could potentially have multiple items. In this case, we can kind of skip over the getPresenter method. We're not really doing anything fancy with like click listeners or anything like that, so we don't have to worry about it too much. But let's say we pass in a list of 3 strings here as our texts list. So in that case, getCount would return texts.size, which would be 3. And then each of getItem and getHolderType would be called 3 times. Once with a position of 0, once with a position of 1, and once with a position of 2. And so getItem would return each of the strings individually, and getHolderType would return the same viewHolder for each of the items. So it would be displayed the same way, each of these items. In this case, it's just a text component viewHolder class, which displays some text with a red background. And so this is what it would look like using our multi-item component in the onCreate method of an activity. We can set everything up the same way we had before with our setContentView, pass in a RecyclerView to our new RecyclerView component controller, and then add our new textView component with a list of 3 strings, one that says hey, one that says that's, and one that says neat. And let's see what happens when we run this. This is what we get. So now we have 3 distinct views that all belong to the same component class. But what if we wanted some of these views to look different, even though they're in the same component? What if we wanted some of these views to be short and green instead? So what we would do is we would revisit our multi-item component class. Specifically, we would revisit the getHolderType method. And instead of always returning the same text component viewHolder class, we would return a green text component viewHolder class for all of the even positioned items. So in that little group of 3 views, every one that was at an even position, so 0 and 2, would be green and shorter. And that's exactly what we get. So that gives us some pretty interesting things to consider. We now have one Bento component with many different views that can all be completely different view types. We can display them however we want. We can have a view holder that gives us a red background or a green background, or formats our data in whatever way we want. And under the hood, each of these views is really just an item in our underlying recycler view. The component controller will ask the component, hey, how many items do you have? In this case, we have 3 items, 3 strings. Hey, that's neat. Then it will create a view holder for each of these items, inflate a view for each of these items, and provide it with the data and the presenter to bind these views. And so what we've done here is we've imposed this abstraction of a component onto the recycler view. That's that blue kind of squiggly line. Our component is just kind of like this abstract grouping of these different views in our recycler view. So now we kind of have this abstract notion of a component where it's a grouping of views backed by a list of data. But that sounds kind of familiar, doesn't it? A grouping of views backed by a list of data. Isn't that what a list view is, or a recycler view is in essence? So a component, we can kind of think of it as a little snippet of a recycler view or a list view. It's its own self-contained list that shows its own data items. So could we make a component that takes in an adapter as its data source and then inflates and binds all the right views? Could we make our legacy list into a single Bento component? So let's clear our palette and go back to what the search page looks like now. We have this toolbar at the top, which we don't really care about too much because it's kind of outside of what we're looking at. We also have these things at the top called search tags, which are kind of like filters. These sit on top of our list view. We don't really worry about them too much either. And then we have our legacy list. So let's assume that we could make all the views in this legacy list belong to one component. So if we can wrap our legacy list adapter in a component, then we could start creating other Bento components, new Bento components, and adding them to the same list view, either above or below this legacy list adapter component. So what we could do is, let's say we wanted to start by creating a start at the top of our list. What we would do is we would remove or delete the logic in our list adapter that creates the view for our alternative search alert. Instead, we would create a new alternative search alert Bento component, and we would add that to our list first, and then we could add the legacy list adapter component below it. And in that way, we can kind of like slowly transition from top to bottom all of these different views into Bento components. So how can we actually make this a reality? Well, we can use what we have created in the Bento framework, a list adapter component. So this is just a special type of component. As its data item, it will actually take in a list adapter as its source of data. Then when the component controller calls getCount on it, it will kind of forward that or delegate it to the list adapter. So what we return is the count of items in the list adapter. Then for getItem, the same thing kind of happens. We will refer to the list adapter to actually get our data item from the list adapter. We don't have to do anything. We're just passing it off to our legacy list adapter to handle all of that logic for us. For the holder type, things get a little bit more tricky, but we do have a custom list adapter holder type that I'm going to go into next that kind of handles delegating the inflation and binding of views to our list adapter too. Because if you remember, list adapters also have a getView method, which allows them to inflate and bind data. And so we can kind of delegate to that also in the list adapter holder type. The presenter is a little bit tricky. We have this kind of wrapper class here, which is just a data class that has a reference to the list adapter and the position. And that's because when we inflate and bind views, we need a reference to the list adapter to actually get our views from our legacy logic. So let's take a look at what the list adapter holder type actually is. So here's the class. It looks a lot like our other view holders. We have an inflate method and a bind method. And in the inflate method, we are given a reference to the presenter. And in the presenter, we can call presenter.listAdapter.getView. And that will call the method that our legacy list view was calling when we were setting this adapter on the legacy list view, right? It will use all the same logic that already exists. We didn't have to touch any of it. We're just kind of we're just kind of adapting it to the Bento ecosystem. Same thing in the bind method. We get a presenter and we can just reference the list adapter there and call getView again to actually bind the data to our views. We don't need to do anything. Well, what you might have noticed is that the inflate method actually has two different parameters, whereas before it only had one. Before we only were given the parent view type, but now we have the presenter and the parent view type. And so that's where this ListView component view holder that we are extending comes into play. So this ListView component view holder is what actually extends the Bento component view holder. And we kind of add our own new inflate method that has a reference to the presenter. So in our ListView component controller, the thing that calls the inflate and bind methods, the component controller will know that the ListView component view holder is like a special type, and it will avoid the normal inflate method, and it will instead call this inflate method that has the presenter and the parent view group instead. And so it's a very small hack, but it allows for a lot of power because we don't have to think about anything when we have our list adapter component. We just create a new list adapter component, provided our legacy list adapter, and then everything is handled for us. We don't have to do anything. So to recap, the getCount method will return the count from the adapter. The getItem method will return the item from the adapter. The holder type will also delegate to the adapter to inflate the view and bind the data. We don't have to do anything at all. And so now we have now we have a Bento component that renders all the things our legacy list view would render, and we didn't have to do anything. So that's pretty good, and that was a lot of code. So I put a GIF of a dog here. I think it fits pretty well with this presentation. Okay, so let's go back to our search page. So now we have a way of wrapping our legacy list view into a self-contained Bento component. So now what we want to do is we want to start creating new Bento components that look exactly like the views that we already have in our legacy adapter. And we want to do this one by one, starting at the top or the bottom. But in this case, we'll start from the top. And there's kind of a process for doing these, for actually creating the new component and making sure that we're sharing code between the two and making it look almost identical. So this is kind of, I'll go through the ancient way of how we would do this typically. And then I'll show you the Bento way and how it's a lot more easy to reason about. So we have the ancient way where we would have our alternative search alert there, that typo view. We would create a new better stack of views adapter. We would create a custom view and add it to that adapter, along with a custom listener, which is also defined all in the same class. And so this class is actually really huge. And then we would take our adapter, we would add the custom view, then we would create our sectioned adapter all the way at the bottom, and add this new section into that adapter. And we would keep going like that for every different section of the search list, 11 times at least. Then we would get our list view and add this sectioned adapter as the adapter. So that we ended up with this big, giant, bloated class that was really hard to follow and that people just kept on piling on more things. So now the Bento way, we have this component controller that wraps our list view, right? We have the list view component controller. And then what we can do is we can call add component on the component controller to add our brand new alternative search alert component. So now we have a list view with one component, the alternative search alert component that's sitting right at the top. Excuse me. Then we go about our ways like we were before. We don't have to convert everything at once. We can keep doing the legacy section adapter things that we were doing before. And at the bottom, we can add a new list adapter component, give it our section adapter, and then now our component controller has two different components. The first one is the alternative search alert component, and the second one is the rest of our legacy list. And so there's kind of a process to doing this. The process that we kind of followed was, first step was to extract common logic that we think we would need to use for the new Bento component, and make sure that we were still using that logic in our legacy code too. So we extract this common logic to some kind of helper class, and then we would try and get that logic under test. And it's amazing how many bugs you'll find when you actually finally get legacy code running under some unit tests. So then what we would do is we'd create a new component, and we would share the same XML file as what we were using with our layout, with our legacy layout. And so this allowed us to create components that looked exactly identical to our existing legacy views, because we didn't have to change anything in the XML. It's the exact same layout. Then what we would do is we would also test the Bento component. So now we can add some espresso tests to our view holder view and actually test and make sure that the right click handlers are working and that our interactions are good. And that would allow us to get everything under test. And then as we would go component by component, eventually everything was a Bento component. And at that point, we were able to convert from a list view to actually using a recycler view. So that was kind of the whole process. And we found a lot of benefits to using Bento in this whole process. The first benefit was that it's very modular. So Bento components are self-contained. They really are like their own little ecosystem. They're extremely testable. We have unit tests for the presenter or component classes, and we have espresso tests for the view binding logic. They're also very reusable. We have Bento components that we use on the home screen of our app, the search screen, and also the business details page that we use across all three, and it's very interoperable. It's also progressive, which was kind of the whole point of this talk, was you don't have to redo everything from scratch right away. You can do it more progressively. It's also scalable, and I mean that from a technical standpoint and also an organizational standpoint. It's perfect for large screens with long lists of kind of heterogeneous views, but also from an organizational standpoint, there's way more clear ownership over who owns a small set of classes versus this giant class where everyone has just kind of dumped things in. And also, it's pretty low overhead. There's no annotation processing, so you don't have to worry about any of that. Our build times were not affected by this library at all. And also, it's pretty easy to learn. The learning curve is pretty short because it's very similar to how RecyclerViews actually work. And yeah, so with that, I guess I'll take some questions. If I don't get to your question, though, my email is targo@yelp.com. Or if you're allergic to email, I'm also on Twitter at Argo_49. Yeah.